Hello, welcome to our lecture series about the mathematics books D2. We were discussing about the proportions of the chapter 1, and we now continue our discussion about the proportions. As we discussed in our last lecture, that we found out that there is a constant ratio among the two variables, and we noted that it is equal to k, and using that constant we can generate a relationship or an equation among the two variables, and that equation if plotted will give us a straight line that passes through the origin, and we said that it is a direct proportionality relationship between the two variables such as y and x. We continue our discussion in this third lecture of proportions. Here we see an example. It is different than what we got in the previous lecture. Here the equation represents y is equal to 3x square, and we find that a table like 1.4 can be generated using 4 different values of x, 1, 2, 3 and 4, which will give us y is equal to 3, 12, 27 and 48 from the above equation. And if we take the ratio of the two rows y over x, then it is 3, 6, 9 and 12, which is not a constant number that was obtained in the previous example. And if we plot the graph between y and x, taking y on the y-axis and x on the x-axis, we find that it is not a straight line, and of course if we use x is equal to 0, it will pass through origin, but it will never give us a straight line. It is a curve that increases when we increase the value of x. Now if we consider the same table and rather calculating the ratio of y and x, we can take the ratio of y over x square, and in that case we will find a constant number 3. So there is a constant proportion between y and x square, not exactly between y and x. So if we plot this equation or this ratio as y is y over x square, then we can see that it gives us a straight line. Of course it passes through the origin. So we can say that from this example that y over x is not exactly equal to constant. In fact, it is a variable which is equal to 3x, a variable that depends on x. However, if we take the ratio of y over x square, then it is a constant number which is equal to 3 in this case. So we can say that there is a proportionality which is direct proportionality among y and x square, not among y and x. So from this discussion we can evaluate something about these two equations. We have to tell us about the proportionality among y and x in these two equations. Number one is y is equal to 5x cubed, and if we take the ratio of y and x cubed, then it will be equal to 5, which is a constant. So that means there is a direct proportionality between y and x cubed. Similarly, for the second equation, y square is equal to square root of x. If we take the ratio among y square and under root x or square root x, it will give us 1, which is a constant number. So that means we can say that there is a direct proportionality between y square and square root of x. Now if we think about the previous example that we discussed in the last lecture about the total cost from a mobile plan, the equation that we found was equal to c is equal to 0.2 n plus 20, where n is the usage in minutes and 20 is a fixed amount of payment or the cost. that was included in the plan, and point 2n was the variable cost. So what we have to find is that we understood that there is no direct relationship between C and N. However, is there any direct relationship between N and C, or some variable? Well, that can be made if we investigate this equation. We have equation C is equal to 0.2n plus 20. So if we subtract 20, that means we'll get C minus 20. And if we declare C minus 20 as a new variable, let's suppose it is D. So C minus 20 is equal to capital D, which is a new variable. Then we can say that capital D is equal to 0.2n. And if we take the ratio of n and capital D, it becomes a constant number. So we can say that there is another variable, which is capital D equal to C minus 20, can be regarded as a variable which has direct proportionality with n. Similarly, in the equation y minus 1 is equal to 4x, there we have two variables which are directly proportional to each other. We have to say what is that, what are those two variables. So we can say that if we declare y minus 1 as a new variable, for example z, so capital Z is equal to 4x, and we take the ratio of z and x equal to 4, then z and x has a direct proportionality. So there is a variable that can have direct proportionality with x, but we have to change y minus 1 to that variable equal, which is z. Now we consider another example. We solve some problem by using the data that we are provided with. We have a proportionality among y and x such that y is directly proportional to x square. That means there is a constant number if we divide y by x square. So that means there must be some equation or relationship between y and x square. So in first part of the example, we have to find that relationship. We are provided that y is proportional to x square, so we can say that y over x square is equal to a constant. Let's suppose that constant is k. So it means that y is equal to kx square. Now we can calculate this constant using the data that is provided in the second part of the example, where we have x is equal to 3. In fact, we can calculate the k value using the data y is equal to 20 and x is equal to 2. So using that data, y is equal to 20 and x is equal to 2, we will find that k is equal to 5. So that means we have actual relationship by getting value of k is equal to 5 is y equal to 5x square. So for the second part, where we need to calculate y given value of x is equal to 2, we can easily find that y is equal to 45. So we can calculate in the third part the value of x, where we are given the y equal to 1.25. So we put that y equal to 1.25 in equation y is equal to 5x square. So we need to calculate the square root of x square in order to get the value of x. So we know that we can have this value of x square, that is equal to 0.25, by squaring 0.5, which means that it has value of 0.25 even if it is negative number or positive number. So we need to use both plus and minus in order to give value of x. Now in the fourth part of the example, we have to actually plot a graph between y and x, and we start with x is equal to 0, we'll get y is equal to 0. That means our straight line will pass through origin, and if we put x is equal to 1, we get y is equal to 5. So using different values of x, we get different values of y, and it will always give us a straight line passing through the origin. This example relates the volume of a solid with the radius. So we have a direct proportionality of volume with the cube of the radius. So we have to find that constant which relates the volume and the radius as the cube of the radius by using the data such that when the radius is 6 centimeter, it yields the volume equal to 905 centimeter cube. So we know that there is a direct proportionality between y and r cube, where r is the radius of the solid. So it means y is equal to kr cube can be written as the equation that relates between volume and the radius. Now we use the value of r equal to 6 and v is equal to 905. We get the value of constant k, which is 905 over 216. So our equation will become v is equal to 905 divided by 216 r cube. So if we want to find the volume for a given radius equal to 10, then we can easily plug in the value of r and take the cube and then multiply with the constant 905 divided by 216. We'll get the volume in centimeter cube.